everybody, it's Mrs. Westmoreland, and this video will go along with your electron configuration notes and assignment. So what we're doing here is we are adding on some detail to the Bohr model of the atom. So Niels Bohr studied the emission spectrum of hydrogen and concluded that the electrons exist in energy levels or shells. And those have numbers. So energy level 1 is the one closest to the nucleus, and energy level 7 could potentially be the one farthest away from the nucleus. But the quantum model adds some modifications and some further detail to that energy shell model. First, it adds sublevels, which are lettered S, P, D, and F. And then sublevels are further broken down into orbitals. And an orbital is simply a space that is occupied by two electrons. So essentially, our electron organization is broken down into several levels. So the first kind of simplest level of organization would be the energy level. And so you can sort of think of those like the floors of an apartment building. So the electron is on the first floor, or the second floor, or the third floor. Then the next level of organization is the sublevel. And so the energy levels are broken down into sublevels, and you can think of those like the apartments. And then thirdly, we have the orbital level of organization, and those would be like the rooms inside the apartments. So an orbital, as we said before, was the space occupied by two or a pair of electrons. And this is really determined by mathematical calculations and equations, and it's really just a mathematical probability of finding an electron in a certain region of space around the nucleus. So we started with Bohr's model of the atom with the numbered energy levels. The farther away from the nucleus we get, the higher the energy level. And then we're adding on these sublevels in the quantum mechanical model and the orbitals. So the first energy level only has an S sublevel, which is made of one orbital. The second energy level has S and P. The S still has one orbital. The P now has three orbitals. Third energy level has S sublevel, P sublevel, and D sublevel. The D sublevel is made up of 5 orbitals. And then the fourth energy level has S, P, D, and F. The F sublevel now has 7 orbitals. And then we can continue out. So this slide is also in your notes and is sort of a summary of how many sublevels there are on each energy level, what the names of the sublevels are, or the letters that we use to designate the sublevels, and then also how many orbitals are in each of the sublevels, and therefore how many electrons can fit into each sublevel. So there are some rules for how we fill up these energy levels, sublevels, and orbitals. And you have a space on your notes to fill in these rules that govern where the electrons go. So essentially, we're trying to find a home in our apartment building for each one of the electrons in an atom. And we have certain rules about where they can go first or second, or what's going to give them sort of the most stability. So the first rule is the Pauli exclusion principle, and it says that 2 electrons may occupy one orbital. So we can have a pair of electrons in a single orbital. But if they're in the same orbital, they must have opposite spin. And the way we designate that in our orbital diagrams is with arrows. So when we have one arrow pointing up and one arrow pointing down in the same box, which would be the same orbital, then that's correct. But if we were to draw 2 arrows pointing in the same direction, then that would be incorrect. So if 2 electrons, which are symbolized by arrows, go in the same orbital, which is symbolized by a box, then they must be pointing in opposite directions, which indicates that they have opposite spin. The next rule is Hunds Rule. And this has to do with filling in the orbitals, which we refer to as the rooms of the apartment building. So before we put two electrons in the same orbital or the same room of the apartment building, we would need to have at least one electron in every orbital of that sublevel. So it's kind of like you have a big family and you have a certain number of bedrooms. You would give each person their own bedroom before you would have the kids share a bedroom. So when we would have a d orbital, which would have 5 rooms, a d sublevel would have 5 orbitals or 5 rooms, 5 boxes. If we had 6 electrons to put in that room, we would give them each their own room first before forcing them to pair up. And the third rule is called the Ospa principle. And this has to do with the order in which the sublevels and the orbitals fill in. And it's always going to go to the lowest energy first, the lowest available sublevel and energy first. And within a particular energy level, the S is going to be less energetic than the P, and the P is going to be less energetic than the D, and the D is going to be a lot less energetic than the F. So within a particular energy level, S would fill before P and D would fill before F. And so you can see here that the correct configuration fills into S before it fills into P, whereas the incorrect or red configuration jumps straight from 1s to 2p. So the difficulty is that the floors of the apartment don't necessarily always fill up exactly in order. You can see on the left there that some of the apartments in the 3rd floor fills up after one of the apartments in the 4th floor. And as we get to higher and higher energy levels, there's even more overlap. So we're going to need to learn a way to figure out which orbitals fill in which order so that we can find a place in our atomic electron configuration for each one of the electrons in a particular atom. So for your asynchronous practice, you are going to use this simulation that is going to allow you to fill in the energy levels, sublevels, and orbitals to construct the electron configuration for different atoms. So what I've shown here is the configuration for argon. So argon has 18 electrons. And so we would start by filling 2 in energy level 1, which only has sublevel S. And that sublevel S has 1 orbital that can contain 2 electrons. Now the first energy level is full. We need to move on to the 2nd floor, the 2nd energy level. So the 2nd energy level has sublevel S and P. S is lower in energy, so we put 2 electrons in the S orbital. And then we go to the 2p, which can contain 6 electrons. Once the 2nd energy level is full, we move on to the 3rd energy level. The 3rd energy level has sublevels S, P, and D. The lowest in energy being 3s, has 1 orbital, 2 electrons. Then 3p can fill with 6 electrons. And that gets us to our 18 electrons of argon. So if I was then going to move on to krypton, which has 36 electrons, I can use that argon as a shortcut to fill in the first 18 electrons, because the first 18 electrons of krypton are going to be in the exact same places as the 18 electrons of argon. But then next, my next 2 electrons are actually going to go into the 4s orbital, because this is one of those places where the energy pattern doesn't follow the direct number order, right? So 4s sublevel here is actually lower in energy than the 3d sublevel is. So the electrons will fill in there first. I still have 16 remaining electrons to find a home for. So the next 10 can go into the next energy level, which is 3d. I still have 6 more electrons left, and so those 6 can fill up the 3 orbitals of the 4p sublevel, which is the next highest in energy. So you're simply using this simulation and filling in from the lowest energy to the highest energy. And when you check your answer, it's going to give you a way that this electron configuration actually relates to the position of the element on the periodic table of the elements. So krypton is in this position where the 4p6 is. And so if we read the periodic table from left to right and top to bottom, we have a way of predicting the energy level, which goes with the row, the sublevel, which goes with the block. The colored blocks represent the different sublevels. And then the columns correspond to the number of electrons in each one of those sublevels. So you can see at the top of the page, we've constructed what's called an electron configuration. The previous page really showed you the orbital diagrams of how those are filled up. They're related to one another. They're just two different ways of expressing this information. And so the electron configuration is going to show you the energy level with a number, the sublevel with a letter, and then the number of electrons in that sublevel with a superscript. So you will use this simulation to complete all of the noble gas configurations, and then once that's complete, you will go to what's called challenge mode, and you will do some electron configurations for elements that are not in that far right noble gas column of the periodic table. So check your answers, look at how the electron arrangement corresponds to the position on the periodic table. Use the shortcut buttons to fill in the first few electrons so that you really only have to use the drop-down menus for the higher energy levels to complete your electron configuration. Best of luck. See you in class.